Good morning, students. We are ready for lesson 116, and I'll start off with telling you which ones you can skip. Skip number 1, number 2, and number 27. That leaves us with 17 problems to do. And we will start off with number 3, which is a ratio, and just kind of do a little bit of a review so that we can continue to put this into our memorization. Here we go. So it says, well, let me just do this first off. We have two different kinds of problems. We either have an inverse problem, the way we solve it with and that is like an x equals somewhat like a fraction, and the other one is directly, which is direct in line. And this is always multiplication. Those are the two types, and also remember the k. The k is the constant that never changes. Let's look at problem number 3. For a mesh gear of fixed radius, the number of revolutions per minute varies inversely. You see the word inversely, so we are going to have this type of a problem set up. And if a particular gear has 100 teeth, we use the biggest number always first. 100 teeth equals 10 revolutions. The constant we solve for, and the constant in this case would be 100 times 10 should be 1,000. All right, so we have that, and then they ask us to what would RPMs result the number of teeth were reduced to 25. This was 100 teeth, now we're going to 25. And of course the next thing we change is the constant, is that right? Never change the constant. Always remember that. We do not change the constant. What we change is this. And 1,000 divided by 25 should be 40. So we have 40 RPMs or revolutions. This is your answer, 40. That's number 3. Number 7, 8, and 9 are new things for today. Again, stay with me closely because this is a memorization. This is the original. What we want to do is get rid of that square root sign right here on the bottom. So let's solve for that. And if you remember, square root times the square root removes this square root sign. And why does it do that? Because 2 times 2 is the square root of 4, and the square root of 4 equals 2. That's why this works. All right, so to do that, we have to multiply it times the square root here again. What we do on the bottom, we must do on the top. That's the key to all of this. All right, so now the answer to square root of 2 times square root of 2 is, remember we just demonstrated, is 2. All right, now we need to solve for the top here. And we take this times this. This is that times that. 2 times the square root of 2 is 2 to the square root of 2. 3 times 1 is 3 to 6 times 2 is the square root of 12. And then we move this down. Still with me? I'm going to erase all of this. Continue to solve. The 12 can be reduced. 12 is 2, 6, 2, and 3. So the pair of 2 times 3 is positive 6 to the square root of 3. Still there. Go too fast for you. Hey, and now what can we do yet? There's one more thing that we can simplify. Watch these numbers in front of the square roots. 2, 2, 2. Can they all be reduced? Now, remember, they all have to be able to be reduced. You cannot reduce 2 of the 3 or any less than all of them. So if we can take 2 into all of this, 2 into 2 goes 1, 2 into 2 goes 1, 2 into 6 goes 3 times. So one more time, I'm going to rewrite this. If this is down to 1, this is going to be the square root of 2. And this is going to be positive 3 to the square root of 3. And this is over 1, which we can do away with if it's over 1. So now here is your answer. We'll be doing these the next lesson. So if you didn't quite get that, we'll get it on the next ones. Here's number 8. It's 2 to the square root of 5. Now, not very often we see a fraction inside of a square root. But the first step is to simplify this. This is the same as square root of 2 over square root of 5. If we have that, we want to get rid of this square root sign here. What do? We multiply it times another square root. What we do on the bottom, we must do on the top. So now square root of 5 times the square root of 5 equals 5. We demonstrated that previously. And then 2 times square root of 2 times the square root of 5 is the square root of 10. Can that be reduced down? No, it cannot. So we've reduced everything down, simplified it as far as we can go. There is your answer. Number 9. 4 positive 2 to the square root of 10 times the square root of 5. Multiply it times the square root of 5. Beginning to catch the idea. This simplifies this to 5. But we multiply 4 times the square root of 5. Becomes 4 to the square root of 5. And 2 is a positive 2 to the square. 10 times 5 is the square root of 50. And still over 5. Okay, got that point. Now the 50 can be reduced. 50 is 2, 25, 5 and 5. 5 times 2 is positive 10 to the square root of 2. What else can we reduce? Can we take 5 and 10 and reduce those? I ask that because I want you to be very, very cautious about doing this, because you must be able to reduce all of your numbers if you're going to reduce anything at all, and that nothing can go into 5, into 4, and 10. So this is the final answer. I'll just rewrite it so you're clear on it. It's 4 to the square root of 5 plus 10 to the square root of 2 over 5. Final answer. 7, 8, 9, number 10. Number 10 is, again, on your graph. And I'm sorry that you don't have the graphing stamp, so you have to use either an old lesson or hopefully maybe Mr. Troy gave you a sheet with graphs on it. Here's our y is x negative 3. And the easiest way to do these, I think, is to move this down. And this is something you're familiar with. Okay, to graph this, we go to the negative 3, 1, 2, 3. And this is 1 over 1, understood to be 1 over 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4. Our line comes down across something like this. Well, we'll put this back up. Y is less than or y is less than or equal to this. You need to check yourself out, but most of the time, if y is less than, then it's going to be in this area. When y is more than, then it's in this area. But we will check ourselves out. we think it's down in here, we will do that. So let's just pick out any, you can pick out any placement that you want, want and try it. So I got 1, 2, 3, 4, 1, 2, 3, 4. That's down in this area. That is a X on the positive line and a -4 on the Y line. Try it to see if this works. This is -4 and 4 for the X. So now to solve that, we have -4 is less than or equal to 1. Is that a true statement? Absolutely true. So we will shade this area in here. I'm not going to do it because I'm using my marker all up. Shade that in on that side. That's number 10. Number 11 is very similar. Is y is greater than 1/2 x plus 1. Remove your greater than sign, put it equal, and we start off with +1 right here, and it's 1/2, so I go up 1/2, up 1/2, up 1/2, here, 1, 2, 1, 2, 1, 2. The line's going to come something like this on your graph. And put this sign back up into here. It says y is greater than. Again, do you remember which side of the line that is probably on? Greater than is usually up in here, and less than is usually down in here. But we would need to check ourselves out. Let's pick out a point here. Let's go again. 4 on the negative. 1, 2, 3, 4. -4 on the X line, and 1, 2, 3, 4. That's up in here. That is up in that area. So we got a +4. Let's see if this works. Y is 4. 1/2 times -4 is -2. X. Sorry. Y, okay, right here. Y is greater than -2. Is that a true statement? Or 4 is greater than -2, I'm sorry. 4 is greater than -2. That is a true statement, so we must shade the top. That was number 11. Number 13, sketch this. This is a added dimension here, so you need to learn this also. 2 plus 2. For the first time, we will deal with both the X line and the Y line. Inclusive signs, if you remember, we solve that on the X line. And the non-inclusive, like this, we solve on the Y line. That clear? This is going to be solved on the X line. This will be on the Y line. So we have a +2 on the Y line. That's going to be here. And the X line, this +1 is going to become a -1. So we have that right here on this -1. Now the other thing is I didn't do. What kind of a sketch is a X squared? It is this. You agree with me on that? Okay, so we have the graph or the sketch of this. All right, now here, where's our point at? We have -1 and a +2, so it's going to be right here is where we're going to, and they're using this sketch. We come down right at this point, and if you would, put +2 here and a -1 here on that sketch. Understood? That was a new dimension for us this morning. That is on number 13. One more, number 20. Not sure why I picked this one out. Nothing, no reason other than just in case you might struggle with the procedure on solving these. 2 √3. Multiplication. 2 times 2 is 4. 2 times 3 is +6 to the square root of 3. -1 times 2 is -2. I need to put that underneath it here. That's a -2 to the square root of 3. And then one more time, this is a -3 times the square root of 9. Add these together, I have a 4. Positive 6 and a negative 2 is a positive 4 to the square root of 3. And finally, square root of 9 is a 3, so I take a negative 3 times positive 3 is a negative 9. Anything less to simplify? There is. Negative 9 and a 4 leaves me with a negative 5, positive 4 to the square root of 3. That is number 20. All right, y'all have a wonderful day. And keep your head up. We are lesson 116. We are winding down.